Hello everyone. We are going to discuss IIT JEE Mains September 4th Shift 1 paper. So let us begin with question number 1. Question 1 says that in a group, 63% of the people read newspaper A. So and 76% people read newspaper B. So let us say the people who are going to read newspaper A are 63. We can take 63%, but we will take 63 so that the total set we will say universal set contains 100 elements. And these are 63 of them. Similarly, those who read newspaper B are 76 in number. And the question is asking us the number of people who read both A and B. And that is given to us as X. And we are asked what is X, what kind of percentage X may have. So we will use the formula n of A union B is nothing but n of A plus n of B minus n of A intersection B. But we know that n of A union B is at most equal to the universal set. So this number will be less than equal to 100 in all cases. So what we have is 100 is less than equal to n of A is 63 plus n of B is 76, n of A intersection B is X. So we get this. So this is going to imply that X is more than equal to 39. Also, one can observe that n of A intersection B is going to be less than or at the most equal to n of A. So this gives us an upper estimate on X. So this therefore I get X is less than equal to n of A, which is 63. So clubbing these two together, I see that X is in between 39 and 63. We took a number, but actually the question is about percentage. So we will have a number which is in between them. So option 4 is a number which is in between them. So option 4 is the answer for this question. Let us move on to the next question. The next question is asking us the value of this integral at 3 minus the value of the integral at 1. So let us simplify this integral itself. So here the function is fx is given to us as root x, integral of root x by 1 plus x square whole square dx. So let us substitute x as tan square theta. So dx is going to be derivative of tan square theta is 2 tan theta into derivative of tan theta, that is secant square theta d theta. So we will substitute this in this. So we will see that this becomes the integral of tan theta by, we have 1 plus x. 1 plus x is 1 plus tan square theta. So 1 plus tan square theta is secant square theta whole square into dx. Dx we have just written as 2 tan theta secant square theta d theta. So if we see, this simplifies to the integral 2 tan square theta, and the secant square, one secant square will cancel. That we can rewrite as cos square theta d theta. So this integral is nothing but integral of 2 times of sin square theta d theta. But sin square theta can be written in terms of cos theta. So this will be nothing but 1 minus cos 2 theta d theta. So this is the integral values so far. But now we know what is the integral of 1 minus cos 2 theta, because it is integral of theta minus integral of cos 2 theta, of course with d theta over here and d theta over here. So integral of theta d theta is nothing but integral of so this is 1 theta. So integral of 1 theta is nothing but theta minus integral of cos 2 theta is sin 2 theta by 2 plus a constant. So this is what is the integral, but this integral is in terms of sine theta, we can convert it in terms of tan theta. So this is nothing but theta minus sine 2 theta is nothing but tan 2 tan theta by 1 minus 1 plus tan square theta into 2 is also there, into 1 by 2 plus this c. So we see that in this case, the function fx is nothing but theta, which is tan inverse x, tan inverse of root x minus 2 tan theta. The 2 is cancelled, so tan theta, which is root x by 1 plus x plus a constant. So therefore, f of 3 minus f of 1, the constant will disappear, and we will see that this expression is nothing but tan inverse of root 3 minus root 3 by 1 plus 3, that is 4, minus tan inverse of root 1 minus of minus 1 by 2. So this expression simplifies to pi by 12 plus 1 by 2 minus root 3 by 4. That is precisely option number 2. Hence our answer is 2 in this case. Let's move on to the next question. The next question here is asking about a right angle triangle ABC, right angled at A. So let us draw a figure. So this is a right angle triangle, right angled at A, and A's coordinates are given to us as 1, 2. C coordinate is given to us as 3, 1, and B's coordinate we do not know, but we want the abscess of the B coordinate. So let us take alpha and beta as the coordinates of B, and we are interested in the abscissa of B. Now what do we know? We know this area is pi root 5. So we know the area of the triangle ABC is pi root 5. Okay. So this is one thing that we have. But what is area? Area is half into base into height. Half into base. The base I can take it as AC, or AB is the base, into the height is AC. This is given to me as pi root 5. Now that means I just have AB into AC is nothing but 10 root 5. But AB I know because I know in terms of alpha and beta I will know AB. So AB is nothing but alpha minus 1 whole square plus beta minus 2 whole square. Root of this is AB. Similarly, AC is nothing but 3 minus 1 whole square plus root of 1 minus 2 whole square. This is 10 root 5. So this is one information that I have. If I simplify this, I see that I will not be able to get rid of beta here, so or alpha here. I will have that in it. So I need one more information. Now, is there any other information available? The information available to us is that this is a right angle triangle. That means I know that slope of AC into slope of AB, or is the product of these slopes is minus 1. But what is slope of AB? Slope of AB is nothing but beta minus 2 by alpha minus 1. And what is slope of AC? Slope of AC is 2 minus 1 by 1 minus 3. So this product is minus 1. So here I get a relation between alpha and beta. So this implies that beta is nothing but twice of alpha. So now I can substitute this beta into this expression. I substitute the beta in this expression, I'll get alpha expression. So if I substitute beta in this, what I have is alpha minus 1 square plus I'm going to have 2 alpha minus 2 whole square under root into this quantity. 1/2 is also there. We have taken care of that 1/2. Into this, that is 3 minus 1 square, that is 4 plus 1 root 5 is equal to 10 root 5. So we can see this root 5s will cancel off and we will get this expression equals this. So from here, we can see that alpha is having this, will get alpha minus 1 actually mod, because we'll have a root square. So that root square will cancel and we'll get this as 2 root 5. So we see that there are two possible values of alpha. So this implies alpha is 1 plus or minus 2 root 5. But here we have only been given one value. So we can say that the abscissa of B is nothing but option 2. So this is the answer for the third question that we have seen. So coming on to the fourth question, we have fx given to us as mod x minus 2, and we want to find what is g of f of fx. G of x is given to us as f of fx. So let me rub this off. So g of x here is given to me as f of fx. So we want to find what is gx. So we need f of fx. But clearly fx is defined to me as x minus 2, mod x minus 2. So what is fx? So fx is nothing but, I know that is going to be same as negative of this if I take x less than 2, and it is going to be x minus 2, same as it if x is greater than 2. We can put equality anywhere, so let us put the equality here. So what is f of fx? So f of fx again makes sense as 2 minus fx whenever fx is less than 2, but we are doing this in the case when x is less than 2, and similarly it is same as fx minus 2 whenever fx is greater than equal to. So now we have to substitute the value of fx. But what is fx? Fx takes two values. So I can substitute fx as 2 minus x. I'm substituting fx, this fx can be substituted as 2 minus x depending on whether I take x less than 2 or greater than 2. So this is for x less than 2. So I will substitute this whenever x is less than 2. But I also have the restriction that fx is less than 2. So this is also fx is less than 2. So I have to have both this as well as this in this case. Similarly, I will write down it as 2 minus fx, but in that case fx can be taken as x minus 2, or I can write in these cases. So there are total 4 cases. So if we write down all the cases, I can see that this can be written as 2 minus x minus 2 whenever fx this 2 minus x, which is greater than equal to 2, or this x is less than 2. Similarly, in this case, we will have it as 2 minus x minus 2 whenever I take x minus 2 less than 2 and x greater than equal to 2. Or again, I take the case when x is greater than 2. So in the case where x is greater than 2, I will write it as x minus 2 minus 2. Again, this is the case where x minus 2 is greater than equal to 2. So I have these 4 cases in which I have the function fx. So let us simplify this fx. So we get f of fx. So this is what we get our gx upon simplification. Upon simplification, we see that gx is just x whenever x is in between 0 and 2. That's the first case, because I want x to be less than 2 and I want fx to be less than 2. That means I want, this is same as saying that 2 minus x is less than 2. So you can see that I want x to be greater than 0, and I want, so this case itself is saying two things. I want x to be greater than 0 also, and I want x to be less than 2 also. So that's the case when x is in between 0 and 2. So in this case, you can see that 2 minus x, 2 minus 2 minus x will cancel out and I'll get x. Similarly, the next case, I see it is just minus x, but this is the case when 2 minus x is greater than equal to 2 and x is less than equal to 2. So that is same as x is less than equal to 0. Similarly, if you write down the other two cases, you will get x in between this for 2 and 4, and this case for x minus 4 for x greater than equal to. So that is our gx. Now we are asked the integral of 0 to 3 g of x minus fx. Now you can see that the integral is changing, the g is changing values at 2 and 0 and 4, but we are only interested in 0 to 3, so we will split the integral at 2. So this can be splitted at 0 to 2, So 0 to 2, what is the value of gx? 0 to 2, the value of gx is x only. Plus, I can split it at 2 to 3, I mean the same part. But in 2 to 3, I will be taking it as 4 minus x. This is nothing but gx written. Now minus fx I have. Fx is again given to me from 0 to 3 only. Again, I have to take fx. That is x minus 2. Again, that splitting is there. All this is with dx, with dx. This is also with dx. So we can simplify this integral from 0 to 2x dx. We can actually solve it. If you solve these all values, you will get the answer as 1. Okay, so moving on to the next question. So I've been asked summation of 50 minus r c6. Now you can see this r is varying from 0 to 20. So typically, what are the terms that are asked? I will substitute for some values of r. So r is 0, I am asked 50 c6. Plus r is 1 means I am going to look at 49 c6. And I keep on doing this. Ultimately, when r becomes 20, I will be at 30 c6. So this sum is asked to me. Now what we will do is, this is 30 c6. So I don't have a term. I mean, the base here is always 6. So what I will do is I will add to this 30 c7 and subtract 30 c7. Doing this, what happens is I can club these two together. It's like 30 c6, 30 c7. 30 c6 and 30 c7 I know is nothing but 31 c7. So this is just going to give me 31 c7. But you see, the prior term to this was 31 c6. So now I have a 31 c6 to work with these two. Okay, I have a 31 c6. Now using the same logic, these two terms will add up to 32 c7. But now a term prior to this was 31 c7. Sorry, 32 c6. So here also I have a 32 c6. So here also I have a 32 c6. So you can see that the trend is continuing, and it will continue up to this 50 c6, isn't it? So this term I'll keep as it is 50 c6, but keep on doing all these terms. So I'm going to get ultimately 50 c7. 50 c7 and this minus this 30 c7 as it is, because this minus 30 c7 I keep this as it is, minus 30 c7 as it is. If I just complete all the terms, so this is what I have eventually. If I look at it, this is what it looks like. But then this again is nothing but 51 c7 minus this 30 c7 as it is. So it comes out as option number 3 in this case. All right. Okay. So let us look at the next question. So it's a differential equation. So clearly this x part is involved in the differential equation. So I want to get rid of this x part. I'll divide by x. So I see that this expression is dy by dx minus y by x is equal to x times, I'm going to have x cos x plus sine, right? So what is the integrating factor? Because this expression looks like dy by dx plus minus 1 by x times y is equal to some function of x, some q of x. So this is like a linear differential equation. So we know that the integrating factor for this linear differential equation is e to the power integral of p of x dx, that is minus 1 by x dx. So what is this integrating factor? So it is e to power integral of minus ln x, which is just 1 by x. So we see that the integrating factor is 1 by x. So our solution is y into integrating factor is equal to q of x into integrating factor, integral. So x into cos x plus sin x. Why? Because this x and this integrating factor x cancels off this dx. But integral of x cos x plus sin x is nothing but the integral of x sin x only, because it's the derivative of x sin x. So this is just x sin x plus the constant. So what we have got y as, so y comes out as x square sin x plus c times x. But what is the constant? What is given to us is that we have this expression. We can see that it is given to us as that f of pi is pi. So pi is equal to f of pi. The moment I substitute pi, I find pi, which is 0. I got the expression y in this case as x square sin x plus x itself. Now what is asked to me is the derivative of this plus at pi by 2 and the derivative it at double derivative of it at pi by 2. So I'll differentiate this. So I want the derivative of this. What is dy by dx? So dy by dx here is x square into derivative of sin x is cos x plus 2x derivative of x square into sin x as it is plus 1. This is the derivative. And we also want the second derivative, that is d square y by dx square. So that is going to be x square into derivative of cos x is minus sin x plus cos x into derivative of x square is 2x plus derivative of 2x sin x. That means I'm going to have x into derivative of sin x. So that is x into x plus 2 sin x into derivative of x. So this is it that we have. So value f double prime at pi by 2. Cos is going to vanish. So the one which is going to remain is the sine expression. And then so you can see that this expression is just pi square minus pi square by 4 plus 2. And this expression is going to be pi square by 4 plus pi by 2. If we add these two up, this part cancels off, and I'll see it comes out as pi by 2 plus 2. So that is our answer. In this case, that is option 1. Okay, moving on to the next question. So what is given here is that it's an ellipse with lattice rectum 10. We know the length of the lattice rectum is nothing but 2b square by a. So this is given to us as 10. So we know that this implies basically b square is nothing but 5a. Also, it is said that the eccentricity is equal to the max value of this quadratic expression. So we want to find max of this f of t, which is 5 by 12 plus t minus t square. We can complete the squares of this expression and rewrite this as 2 by 3 minus t minus half whole square. So we can see the max of f max is nothing but 2 by 3 only, which is given to us as the eccentricity of the ellipse. So we have E here, and we want a square plus b square, but we also know b square in another way as a square into 1 minus e square. So we have it as a square into 1 minus e square, which is 4 by 9. But b square we have already said is 5a. So this gives us the value of a itself. So this implies a is just 9. Therefore a square is 81. But once we have a square, we have b. B square is 5 into that expression 9, that is 45. So b square is 45. So we have a square and we have b square. So a square plus b square is 81 plus 45, which turns out to be 126. Okay, moving on to the next question. It said that alpha and beta are roots of this expression. So what we know is sum of the roots and the product of the roots. So sum of the roots is known to us as alpha plus beta is 3. And we also know the product of the roots, that is b. Similarly, gamma delta are the roots of this. So sum of the roots is known to us as 6, and the product of the roots is known to us as q. Now, what is said further that alpha, beta, gamma, delta are in increasing GP. If they are in increasing GP, I can take alpha itself as A, beta as AR, gamma as AR square, and delta as AR cube, because they form a GP. Okay. So I have alpha plus beta, I have gamma plus delta. So these two values I know actually. So I know alpha plus beta is actually gamma plus delta by 2. And alpha plus beta, so this in this I can substitute the values of alpha and beta. So A plus AR is same as AR square plus AR cube by 2. So I can cancel out A because A is not 0. Why? Because A is an increasing GP. So if I cancel out A, I see 1 plus R is equal to, I can again remove R square out from here, 1 plus R by 2. So this is going to imply that R square is nothing but 2, because 1 plus R will cancel out, otherwise R will be equal to minus 1, which is not possible. So R square is 2. So once I have R square as 2, all I have to do is substitute the value of R square in the expression for 2q plus p by 2q minus 1. But what is 2q? 2q is nothing but 2 times gamma delta plus p. P I know is alpha beta. By same expression, I am going to have 2 times gamma delta minus alpha beta. And I already know what is gamma, what is delta, because I know the value of R square. So I'll substitute these values in it. So gamma expression is nothing but AR square. So let us put it as 2 times of A R square. Maybe let us write in R first of all. Into I'm going to have AR cube plus I'm going to have alpha beta. Alpha beta is nothing but A into AR. Similarly, the expression I'm going to have is 2A R square into AR cube minus A into AR. So you can see that all the A's, we get rid of all the A's, and we see that this is just 2R to the power 5 plus R by 2R to the power 5 minus R. And we already know the value of R is nothing but root 2. So we can substitute the value, it's plus or minus root 2, but we can substitute in here. We see that this R will also cancel out. So we'll see that this is just 2R fourth plus 1 by 2R fourth minus 1. We don't need R's. We can write R fourth directly is 4. So it is 2 times 4, that is 8 plus 1, 9 by 8 minus 1, that is 7. That is 9 by 7, that is option 3, as we have already seen. Okay, so let us move on to the next question. The mean and the variance are given. So this is a simple question. Mean means the average of all these. So the average of all these numbers is given to us as 10. That means 5 plus 7 plus so on, and 14 plus A plus B. Average, these numbers are 8 in number. So this by 8 is given to us as 10. So this gives me that A plus B value. I can see that A plus B comes out as 17 here. Also, its variance is given. Variance we know is nothing but variance. The formula for variance is nothing but summation of xi squares by n minus mean square. If we substitute in the values, so this is going to imply the variance, that is 13.5, is equal to all these squares minus the mean. So squares of individual numbers are 25 plus 49 plus 144 plus 100 plus 225 plus 196 plus a square plus b square. These by n is 8 only, minus the mean which we have already been given as 10. So 10 square, that is minus 100. So if you see this, this expression again involves an a square plus b square. This simplifies to a square plus b square as 169. Now we have two expressions in a and b, and we want the value of a minus b. We want a minus b. But if a square plus b square is given, means I know what is a plus b whole square. This is same as a square plus b square minus 2ab. This is 169. So I know what is a plus b whole square. So a plus b whole square from here can be said as 169 plus 2ab. This is a plus b whole square, right? So this a plus b whole square is what I have, and I'm interested in the value of a minus b. So a minus b is what? So to get a minus b, I'll go with a minus b square, because a minus b square I know is a square plus b square minus 2ab. If I add 4ab's on both sides and subtract 4ab, so if I will add 2ab and subtract 2ab on all sides, then I see that this is nothing but a plus b whole square only minus 4ab. Okay. But I already know this value, so this is just 289 minus 240, that comes out as 49. Therefore, I get a minus b mod as 7. Okay, moving on to the next question. So here S is given to us as a series. So what is this series given to us as? Let us write the terms. So the general term we can see is 1 plus. We can write this as summation of every time. 1 minus, it is 2 square, 4 square, 6 square. That means in general some 2r whole square into, we have 1, 3, 5, so on. That is something like 2r minus 1. This summation from r varies from 1 up to r is equal to 10. So this is the summation that is there. This is the summation that is there, which is given to us as, we will simplify this summation. So this is like 1 plus summation of 1 minus this summation. So the summation we can see is nothing but 8r cube minus 4r. This is from 1 to 10. This is also from 1 to 10. So all we have to do is just substitute the formulas for summation of 10 is just of 1 is just 10. Summation of r cube formula we know is 8 as it is outside. This is n into n plus 1 by 2 whole square. That's the summation formula. This was r square. So minus the summation of this is 4 into, and this is minus, so minus makes it plus 4 into 10 into 11 into 21 by 6. So this is the value. So if we simplify this, it comes out as 11 minus, I'm going to have this expression simplified. So maybe I can remove this minus out itself over here, because I want to put it in that specific format. So this 8 is, so I can see that this is just 4, not 4, 2, because this is 2 square, that will cancel off with this. And this is 10 into 11 square. So that is 110 square. And I've removed minus, so I'll get a minus out here. I'll get this as 140 into 11, but then I'll take this 2 inside with this. So this is what I have. So if you rearrange this expression, it looks like 11 minus 220 times 103. So that tells me my alpha and beta. So I have alpha value as 11. So alpha comes out as 11 and beta comes out as 100. And that is option number 2. Okay, let us look at another problem. So we want to find the number of solutions of this. You can see that x is just any real numbers. So this is greatest integer of x square plus 2 times of greatest integer of x. Because this 2 is an integer, I can remove it outside. So plus 4 minus 7 equal to 0. So this is just like greatest integer of x square plus 2 times greatest integer of x minus 3 equal to 0. So this is like a quadratic in greatest integer of x, or you can see that it is greatest integer of x plus 3 into greatest integer of x minus 1 is equal to 0. So this is going to imply greatest integer of x is either 1 or greatest integer of x is minus 3. If greatest integer of x is 1, this itself tells me that x can take values from everywhere, from x belongs from everything from 1 to 2. So here only I can say that there are infinite solutions. Because, or you can also have this x is from minus 3 onwards, so x can also belong from minus 3 to minus 2. So that's also saying adding up to more infinite. So in this case I'll have infinite solutions.